Before developing any EanTime applications, let us discuss the environment used for such development. To develop EanTime real-time applications, use Visual Studio with either native C or C++ as the programming language. Currently 2005, 2008, 2010, 2012, 2013, 2015, 2017 are supported. We will refer to these compilers as Visual Studio. In the real-time environment, both the C language and the C++ language extensions can be used. For developing Windows applications, any appropriate tool can be used. Header files and libraries are delivered in a format understood by Visual Studio. Both native and managed languages can be used. Visual Studio includes features such as defining a project, adding files to the project, editing the files, building the executable file, and debugging the resulting executable code. EanTime applications use all of these. Wizards are provided that automatically prompt you for the information needed to create source code templates for your real-time applications. Once you complete the template, you edit the code directly. To develop a Windows application that needs to communicate with a real-time application, the NTX functions can be used, or the EanTime.NET package. The NTX header files and libraries supplied with EanTime are in a format as expected by Visual Studio. To create a real-time application using the EanTime application wizard with Visual Studio. 1. Invoke Visual Studio. 2. In the File menu, select the New Entry, or on the Start page, select Create Project. 3. In the New dialog box, select Projects tab. 4. In the New Project dialog box, select EanTime projects from the list of project types, then choose the application wizard, name the project, choose the location of the project directory, and click the OK button. Continuing to work with the wizard. 5. In the EanTime application wizard, select a project type. Then, for a full-featured project, choose elements to include in the real-time application. A real-time application contains any number of the elements pictured above. Global settings apply once and for all. 6. To begin defining the attributes of the selected element, click on the Add Element button. 7. Define the attributes of the selected element. OK allows you to select the next element. 8. Edit element or delete element allow modification or removal of an element. Elements can be repeated, for example you can select more than one regular interval thread. 9. Generate process should be selected when all elements have been defined. 10. Click OK in the New Project Information dialog box to generate your project files. Note that there are also wizards to generate an EanTime static library and an EanTime shared library. After being generated by the EanTime application wizard, a project, named test, includes these files. Project solution or workspace, test.sln and test.suo or test.dsw, and project definition file, test.vcxproj and test.intp or test.dsp. Main module test.c. Project header test.h. Utility function file utils.c. Implementation files, such as sserver1.c, int7c etc. Text file called readme.txt that describes each generated file. After successful building, the result is an executable file with a RTA extension. Although this has the same format as an exe file, the two cannot be exchanged. There are two debuggers, each having its own pros and cons. The Visual Studio debugger can be used in Visual Studio 2005 and later with EanTime projects, those that have the pink EanTime icon in the Solution Explorer. You use Visual Studio for all interaction. Spyder is a separate program and has its own user interface, although it uses many of the same function keys as Visual Studio. A relevant difference between the two debuggers is that Spyder only suspends the thread that hits a breakpoint, whereas the Visual Studio debugger suspends all threads in the process. When a fault in an InTime app is detected, such as a bad address resulting in a page fault, the Fault Manager pops up. There are choices to let Spyder or the Visual Studio Debugger handle the fault.